In this video, I'll walk you through how we can model a functional hinge using Build123d. Let's begin with the basic components. First, we define some key dimensions, like the width, length, barrel diameter, thickness, and pin diameter, so we can reuse them throughout the model. Then, we create the hinge profile using a grid layout. We place alternating rectangular tabs using grid locations, which help define the hinge leaves. We subtract from this profile to carve out space for the barrel. Next, we define the hinge pin. This includes a cylindrical body with a rounded head on top using fillet, giving it a realistic mechanical look. After that, we construct one leaf of the hinge, which is the external or internal flap depending on the inner flag. We draw a detailed sketch profile using arcs and lines, then subtract a small circular hole for the hinge pin clearance. We extrude this sketch into 3D, intersect it with the hinge profile to create the tabs, and add countersink holes for fasteners using a grid along the length. If the current leaf is external, we insert the hinge pin into position. Then we define joints. There's a rigid joint named leaf to connect the hinge to other parts, and either a rigid or revolute joint for the hinge axis, depending on whether the leaf is internal or external. We also add cylindrical joints at each of the countersink holes to represent possible attachment screw movements. Finally, we visualize everything using show-all. Now let's see how we can turn this into a reusable class. I've wrapped all of the previous logic into a class called hinge, which inherits from compound. This class accepts the same parameters: width, length, barrel diameter, thickness, pin diameter, and an optional flag to specify if it's the inner or outer half of the hinge. The internal structure of the class mirrors our earlier code. We build the profile, the pin, and the leaf, attach the joints, and finally combine them using super init. This makes it very easy to create multiple hinges. For example, here I create both the inner and outer parts by simply calling the hinge class with the required parameters. Lastly, I build a box and a lid to demonstrate how the hinge can be integrated into a design. I even create a notch in the box for the hinge to sit flush and define a rigid joint to attach it. The result is a highly modular and functional hinge system that can be reused in different projects.